with One Source on behalf of Rockwell Automation, and we're going to go ahead and talk about theory of operation, understanding the operations of the unit, how to operate it, clear faults. We're going to talk about the pad-mounted transformer, the soft starters, the MCC, and the VFDs. These are, I think you guys call them 07 PMP 12001 to 12005. 12001 and 2 are the VFDs, 12003, 4, and 5 are the soft starters. These are all 300 horse motors for your effluent. I believe it's for your effluent, right?
Reclaim.
Oh, okay, for the reclaim. And it's all in a single headworks. And you guys also monitor it on SCADA. That's kind of, I think that training is on another person.
Yes.
So we'll actually just talk about the equipment itself, and we'll go into the rooms. First thing I want to talk about is safety considerations, and you know, this, you probably hear it all the time. You know, being you guys are operators versus electricians, if you do see something wrong, call an electrician. Don't work on anything hot. This stuff will bite you pretty good. Pad-mounted transformer. Let's get into that. There's heat and oil levels. We don't want the transformer to get too hot. We always want to make sure there's oil in it. We want to make sure that none of the paint is flaking on the outside. So if you guys are ever doing just a walk around, just look at some of this stuff. You know, if you're looking at the transformer, make sure it's not discolored, the paint's not cracking, you know, as if it did heat up. If you do see any of those conditions or the oil level is low, call maintenance and get those guys in there, because the last thing you want to do is lose that transformer. When we go out to the unit, we'll just show what those indications are. I don't know if that's a maintenance job, but it's always good for operators just to kind of walk around and see what they see and just take general observations and then pass it on to the POC reporters. Well, I have a do's and don'ts section. Well, on this one, everything's a don't. Just don't really touch the transformer. Leave it alone. There is a lot of high voltage in there.
Can you comment real quick on what the transformer does? You know, simplistic manner.
Okay, the transformer is 12 kV service here, right? We're taking 12 kV and we're bringing it down to 480. So basically what we're doing is we're taking high voltage, low current, and we're transforming it to low voltage, high current. And the reason why they do that is if you look at these lines that are out here, 12 kV lines, and you'll see transformers out there, is you can't pump a tremendous amount of current through smaller wires without the wires heating up. So to get over that, they bump up the voltage. And it's easier for transmission to get from here, let's say, to the power plant. And if they just ran 480 out here, there would be giant copper cables running all over the place. It's kind of Edison's idea back in 1890 when the light bulb came up. Let's do everything DC. Well, if we did that, we'd have a power station every 5 blocks. I mean, it would just be, it doesn't work. And you know, and then Tesla came up with the AC circuit. You know, and you guys know what AC is, right? I don't know if you don't, but and through AC we can use transformers. And with the use of transformers, we're going to bump the voltage up. This transformer is actually bringing it back down. So we need a lot of current out there. I think it's a 2,000 amp bus, and we'll at full load, I think we pull about 1,100 amps with all the pumps running. I'm not too sure if you guys actually run all the pumps because we'll hit high pressure. I think it was borderline.
I think 4 is meant to run, 5 is like the last ones that stands like.
Yeah, exactly. I remember seeing when the 5th pump came on that it was intermittently hitting high pressure. And you can see it, you won't see it on SCADA on the alarms, the high pressure, but let's just stick with the transformer right now. Do you guys have any questions regarding transformers and this pad-mounted transformer? And then only let qualified personnel work on the transformer, especially on the 12 kV side. There's actually electrical certifications to be able to even touch that side of it. I'm not too sure if there's a main feeding it. Is there a main feeding it? Yeah, I don't know. We'll have to go out there and look. The VFD, do you guys know what VFDs are and how they work? You guys seem pretty experienced operators, so I'm not meaning to insult anybody's intelligence or anything like that, but I'm going to start at the basics, where a VFD, these ones here, they call them 18 pulse VFDs. So basically what that is we'll bring the 480 in out of the transformer, and then there's a transformer, and it's going to shift the phases. So instead of 3 signs of sine waves, there's going to be 9 signs. And what that does is reduce the harmonics going back into the system. So there's the left section of the VFD, and it'll come into the AC. We'll move it to 3-phase to 9-phase through the phase shifting transformer, and then we'll convert it to DC. And then there's a DC bus in there, and then that DC bus will fire based on speed command. And that's where when you hear a VFD run up and it's you kind of hear it. That's its firing. It's firing faster than we can hear it, but barely. You notice it's there. And then as the VFD is coming up, that's what you hear. When we go out there, we'll go over status indicators. There's run. There's a little him display. Are most of your drives out here Allen Bradley, or do you have a mix? So you basically have the door-mounted him. It's like a little keypad with a display, and it shows speed, frequency, amps, parameters, faults, that type of stuff. So we'll go through the him, how to clear faults, how to read the faults. We'll demonstrate how to recover, just in case of an event. And then we're also going to talk about some of the things that can shut the pump down, such as high motor temp, low flow. There's a low flow switch out there. So when you go to run the drive or the soft starter, the check valve needs to open and come off that switch in a certain amount of time. And if it doesn't do that, the electronics logic thinks that it's not running, or that there's no flow, or the check valve is bad, and we don't want to deadhead the pump, so we're just going to shut the pump off. And I think it's set for about 10 seconds. There's an initial delay on that, because once you start the pump, there's no pressure, or there's no flow. So we put a delay on it, an initial delay. So if we go out there and there's a pump running, you can actually push on the switch, and the pump will shut off. Another standby pump will come on based on the control strategies and the control streams. What makes an 18 pulse different than most drives is the phase shifting transformer. And it's good for harmonics. It keeps the voltage on the transformer side, and then even on the other side of that, more balanced. Because as the VFD starts up, it's the current and the voltage will separate. The motor's not up to speed yet, and since it's not at speed, the phase starts shifting, and it starts interacting with all the other equipment in the plant. And all of a sudden you'll see like another motor do something weird. You're like, why did that do that? Could be from way over here. So we do harmonic studies, we watch that, we put in really good equipment to make sure that, we kind of design it into the system. Explanation of how the unit connects to SCADA. Everything is through dry contacts. So if the VFD had a fault, and it's the same with the MCC. Let's say, for example, the low flow. You'll see the lights flicker on the MCC, or let's say when we start a pump up, you'll see the low flow light come on, but it won't report an alarm until the timer's done. So you can go out there and let's just say, like, well, I received a low fault on SCADA. I don't know, was it a real alarm? Was it not? Was it flickering? What kind is it? You could actually go out to the room and watch the lights come on, and you'll see the high pressure light. As high pressure dings just for a second, you'll see that light come on, but it's not going to report to SCADA, so you're not going to know that happened from the controller. But you can see it out there in the equipment room. Once the time delay is done, the alarm will latch and it'll shut the drive off, the light will stay on, and you guys will get your alarm. So we have low flow, high pressure, motor temp, and I think there's one more. There's 4 of them.
Is this low level, low flow? Or is that
Let's see, we have high motor temp, high discharge pressure, high vibration, but I don't believe that you guys have vibration switches on your motors. So I don't think that circuit's actually enabled. I never saw it starting up. I never saw those wires landed. I don't think that the motors have 5 switches. And we have low discharge flow. And those are the shutdown conditions hardwired to devices that are out in the field that'll shut it down. Other than perhaps maybe you lost a phase. The VFD will shut down on a phase failure. Let's say you lose one of the 3 legs. You could trick it, maintenance could trick it, and you could run it. Will it work? Will it not? On a VFD, we take the AC and we convert it to DC and we convert it back to AC. So as long as we have enough AC to make the DC and keep the DC up, the drive will run. And I've seen it where even bigger drives in here, and you pull phase A. For some, I wouldn't necessarily pull it, but I've been in situations where phase A came off, and why did the drive keep running? When the amps came up, it's pulling more amps off the 2 loads because it's trying to get it off the 2-phase versus the 3-phase to keep the motor going. It's just the way that design works. And we have the same kind of hardwired shutdowns on the soft starters. One thing to keep in mind, let's say if for some odd reason you cycled power and you cycled it back up, there's an initial delay. That's a start delay, and it's just to allow the electronics to boot up. And so you can go out there, throw the disconnect, and you throw it back on, and you'll hit start, and it's not going to start. Why isn't it start? I'm hitting the button, there must be something wrong. Let's call everybody. Well, there's really nothing wrong. Just give it a minute or 2. Let it time out, because what it's waiting for is all the electronics and safeties to come alive. And once they come alive, that time delay relay is going to latch, and it's going to allow the control circuit to turn it on. So just keep in mind. Wait a minute or 2. A lot of this is these are the electrical prints. I want to show you guys out there on the equipment what the buttons are, start, stop. Being this is an operator class, I guess it's geared a little differently. Do you guys have any questions regarding operating just an MCC in general? Or in a VFD or a soft starter? You guys know what the difference between a soft starter and a VFD is?
Well, the VFD is variable control speed, right?
Right.
And the soft start, it still doesn't take the full load, but it's like, I don't know, 50% of the load or something on it, or.
Okay, close.
Yeah.
So a VFD is a device in which we can control and vary the speed of the motor, a variable speed drive. Some people call them inverters. And you'll see the same type of inverter when you go buy one for, let's say, for camping. And you plug it into your cigarette lighter and it produces AC. So you get from DC to AC. It's the same as a drive. So sometimes drives are called AFDs, VFDs, inverters, because it's an AC front end with the transformer. We convert to DC, the DC back to AC, and we control the AC. So we can slow the pump down. Motors can go typically 6 to 60 hertz in speed, but the pump is really what's going to determine how low you can go because of the curve of the pump, the seal water, and I think out here the min speed of the pumps is 35 hertz. So you're only going to control from 35 to 60 to maintain your pressure. It's not going to go any lower. And I don't know if you guys have manual controls where you can go through SCADA, go to manual, and say go at 20%. I don't know if you guys have that functionality.
Yeah, I don't know. If we do, they didn't show us that in our training.
Okay. And sometimes it's not there because it's an auto system. But we can do it in manual, and when you put it into hand, you can adjust the speed with a potentiometer 0 to 100%, but it's 35 to 60. You can't run it lower. It's set in the parameters of the drive. It just won't let you do it. It can be adjusted, get maintenance out there. I would only have those guys really kind of make those things, because you can break the pump, burn up the motor. I mean, there's severe things that can happen. So then a soft starter there's no AC to DC conversion. What we're doing is we're chopping the AC, and we can just go from 0 to 60 hertz in a certain amount of time. So instead of like a contactor pulling in, and that motor's just going to spin right up, well, we don't want to spin these motors up that fast, and there's also inrush currents that when you spin up a motor that fast, you're going to pull a lot of current off the grid. And maybe you see this, or some other people may see it, or you guys heard about it. If you turned on all your motors at once and it had a huge inrush, it's very expensive. The utility is going to get you for inrush currents. So throw soft starters on there. So over 15 seconds, that inrush is kind of ramped, and it's not this huge spike of power coming in to get the motor to turn. And that's typically why soft starters are used. That, and it's easier on the motor. But you're not going to be able to control speed with it. It's just, once it gets up to fixed speed at 60 hertz, it's going to lock at 60 hertz, and it's just going to stay there until you turn it off, and then it's going to ramp down. So all it does is to get up there, you have a time, and then we're just going to chop the voltage until it gets up to speed, and then we're going to allow the full sine to go through. So in the beginning, there's a little sine, a little bigger sine, and basically all we're doing is breaking it. That's a soft starter. These ones are a little larger, but the theory's all the same, whether it be a 5 horse or 1,000 horse. There's main breakers. We'll go through the power distribution. Do you guys ever deal with having a cycle power, or you guys don't really touch that kind of stuff? Call maintenance. Right. But you did mention you do run it in hand sometimes, right? If you have to.
Very rarely. We had some work out in the road, and the system moved down, and we had to bring it up real slow.
Okay.
But that was years ago.
Okay.
It happens, but not very often.
Okay, but we'll demonstrate that. You know, just it's pretty easy actually. Trying to think some other questions I have regarding operations. Do you guys have any questions? So regarding, I'm going to go back to flow, pressure, and high temp. There are delays on all of them, and they are adjustable. So maybe you are pinging pressure up a little bit too high, you can always ask the operator or the maintenance, you know, maybe we can adjust it a little bit. We're shutting down, maybe we shouldn't. You guys are trending it, and you're like, you know, we're fine. And just, I think as time goes, I've seen plants kind of get tuned as they mature. And
you talk about adjusting
the shutdown limits?
Set points.
set point, so that would fall under our DCS.
Well,
guides.
let's say it's kept shutting down high temperature, and it was just borderline there.
Mhm.
Then we would write a work order and have them maybe, if they could adjust it a little bit so that doesn't shut down. But we wouldn't make that change. But
The temperature you can adjust, you can just adjust the delay.
oh,
The temperature is a switch.
okay.
Pressure you can adjust. Flow, you can adjust, but it either you have flow or you don't, and it's working off of a switch and a lever. So either the mechanical's not working, but what you can adjust are the delays. You know, the initial delay for the low flow and the high pressure and the motor temp. Like, how long does that alarm have to be active out there in the equipment room before it triggers an alarm and shuts down? Just take caution and don't crank it all the way to the max. Those alarms are there for a reason. That's to protect the equipment.
Pretty easy group on.
Yeah, you guys are awesome.
It's because we don't do any with the maintenance and the electrical stuff, that's why.
Right, and this is pretty electrically intensive.
We can go out to the field.
Yeah, let's go out to the room.
For your 5 300 horsepower motors that we were just talking about previously. This is pump 1. This is the VFD section. There's 3 sections to the VFD. This is the 18 pulse, where I was talking about. The 18 pulse is in here. In here is the controls and the drives, the operator interface, a power monitor for display. So right here, I touched on it, and it looks like that. So I'm going to go File Manager, PM5000 M1A. I'm going to hit Run. It's already running. somebody hit exit right here, and you ended up back at that screen. So I'm going to go to main. This is kind of the touchscreen configuration, IP, all that kind of stuff. You really can't break anything by going in here, but if you hit exit, you'll end up here and you won't see what's running. So communication, I'm going to go down here, I'm going to select this pump, and I'm just going to hit run, and then there's the screen. So overview, here's our amps, our currents. We'll go back to main. We can watch our voltage phase to ground, phase to phase, our current, our average current, our frequency, and our average frequency. We can check out our power. You can see what kind of demand is going through, kVAR, kVA, lead lag, power quality, volts, amps, the K factor, IEEE and IEC. A lot of that stuff, unless you're looking for anomalies that something's wrong, you're really not going to get into there. We're looking for current, frequency, and voltage. If you have all of those, typically things are going pretty good. And energy demand, kilowatt hours forward. That's energy coming into this room, not energy leaving this room. There's no way for energy to actually leave this room. There's no generator. So then we can go back to the main screen, and I'll just keep it right there. And now we can watch our currents. Any of you guys want to go through this and just kind of play with it? No? All right, we got a hymn here. This pump is actually running. This is pump 2, and that's pump 1. Control power is on. What I was talking about, the delay, if you did have a power cycle, the timer has to time out. You'll get the control power on. You have an E-stop right here, and you also have a lockout stop on the pump. So in a oh-no event, go ahead and hit that, and it'll shut down. The pump is being called, which it has a command to come into it. SCADA is saying, hey, run the pump. Now it says, hey, I am running. This light will come on if you have a VFD fault. They're all push to test. So if you're not too sure, just go ahead and press the lights. Because sometimes maybe a bulb might be bad. You actually have a fault, and just go in here. Hand off auto. If we run it to hand, you can control the speed using this potentiometer. You'll see the speed come up here on the screen. Now, if for some odd reason on this screen you don't see hertz, amps, RPM, and you see maybe a screen like that, just keep hitting the escape button, and you'll come back to the main screen. And then you can see how fast we're running. We're running at 78%, 43 hertz. Without a calculator, I'm kind of guessing. 47? Oh, 47? Yeah, never mind. Hey, I was like, wow, you're pretty fast. So when you are in hand, you got a green start button and a red stop button. If by any chance you have any of these alarms, and it's going to internally latch the electronics in here. So if you did get a high pressure alarm to SCADA, you can reset from SCADA. I believe they have it from there. It'll reset this. If it doesn't reset and the alarm is still there, maybe there's something wrong with that communication link. Come out here and try this reset button. If that doesn't work, call maintenance. Another thing you can do is, if it does have a fault, maybe maintenance isn't around, you want to maybe just clear the fault and try it again. You come in here, I'm going to escape. I'm just going to escape again. I'm going to arrow up to diagnostics. I'm going to hit enter. Faults. So we have alarms, faults, status info, device version, and it's just going to, the menu is going to go in a circle. So come on down to faults, hit enter, and we have fault info, view fault queue, and then down here, clear faults, and then clear fault queue. And then you could reset the device, but don't do that. Just try to clear the faults. If the faults don't clear it, give maintenance over here. It may be Sometimes it's just an anomaly. Maybe the grid went low just for a second. You never know, and you could recover without bringing maintenance in just by clearing the faults. When you do that, just put it to off. Don't try to do it when that's trying to run it. And make sure the VFD is at 0 hertz to try to clear the faults, and then put it back into remote. SCADA will try to grab control of it and get it back up to speed if it can. Or it'll say the fault right on the top. It'll say, hey, I'm faulted for over temp, or I had a bad lunch, or whatever reason. And then to get out of here, just keep hitting escape. If you ever do walk through here, just check the fans, make sure things are running. Just if you're walking through. I don't know if that's part of your routines, but if you do walk around, maybe if you see these real dusty, get a maintenance guy out here, because this is the intake. So maybe they're clogged. You guys are like the drivers, they're the fixers, so they'll check your oil as long as you say, hey, can you check my oil? And they'll come out. Here's the main disconnect. If you ever needed to remove power, don't be scared to go ahead and throw this down. Now, to throw it back up, I would have maintenance do that. But if you're in an event where you need to just shut the plant down, try the e-stop. The e-stop didn't work, throw that. Then you will shut down. You won't shock yourself. But when you go to turn it back on, have maintenance do that. Because there might be something wrong that you could have arc flash in here. It could be very dangerous if something wasn't right. But I have no problem turning it off. I have no problem telling anybody to turn it off, because that's a safe situation. It's also the same for pump number 1. We have the same power monitor. We go in here. And this one, if you hit exit, you'll go back to that screen, and you just have to run the program. We have the same HIM. We got an hour meter. I think you guys have an hour meter recording in SCADA. I don't know. But we have an elapsed time meter for maintenance intervals. Whatever you guys or the motor guys said, hey, every 1,000 hours changes. I don't know who keeps those logs, or do you guys monitor the hours? How does maintenance know when to come out and look at something? Maintenance does? Okay. Say again? And they're up for monitoring that? Yeah. Okay, so you guys wouldn't say, hey, seems to be a lot of hours on here. I haven't seen anybody out here.
They have a good system. Okay. It's the same controls. These are identical units. Pump 1, pump 2. Oh no, and the e-stop. We'll go over here on this side of the unit. Main power is coming in to here from the transformer. So we have 480 with a main breaker that's sitting right here. If you ever see this handle tripped, this whole plant's not going to come on. If you go ahead and throw this one right down, we're going to shut down all 5 pumps. Typically don't want to move this one, but if you had to, go for it. We got a surge suppressor, a voltage surge suppressor, like detect spikes, kind of clean up the system a little bit. If you see any of these lights red, blinking, or off, and they're not green go, let maintenance know. This unit doesn't have to be on for the system. It's just a surge suppressor, kind of like what you'd put on your computer to protect it. We have a main power monitor up here, and this is watching. Let's see if this is backwards. Okay, yeah, I'm gonna get in there on that. But this is you can watch your power, your voltage, and your frequency all from here, and this is monitoring your main power from your main bus. Local disconnects. This is another disconnect for this pump. This disconnect is for that pump, and the free soft starters. Start, stop, reset. It's all the same kind of control for the start. So if you did shut it off with the disconnect,
and you hit start, it's not start. Just give it a minute, like I was saying, and it'll start up. If you have any of your fails, they'll show right here. High vibe, high temp. This one, SSRV, is another name for a soft starter. So SSRV means that the soft starter that's down here failed. Give maintenance a call. Oh no disconnect and the E-stop. Also the same in here. Then do you guys know how to get in here to the fault queue? Do you want to try it?
This is Escape.
Escape. Diagnostics. Enter. Faults. Enter. So you can view, you can clear them, and you can clear the fault queue. So then I would go here, and then I would hit enter, and then it'll clear the faults. You want to? Yes. Right? And then you can exit back out. And then try starting it again. And if that doesn't work, call maintenance. But you can at least give it that one attempt, because it might just be an anomaly. You never know. I don't know where you guys cross over in terms of...
Yeah, we would do that.
Okay. And so it's the same as here. None of these guys are running. I guess the two VFDs are maintaining your level.
They come on based on our level.
You're right. Right. So the level is maintaining with these two.
When we get higher, it kick on.
Mm-hmm. Like a lead lag, a standby, kind of. Right. Right. Do you guys have any questions about any of this equipment in here? Pad mounted transformer. And from an operator perspective, there's not anything you can control, do, or an alarm, but we'll just do a walk around. And one thing we want to look for is, if you see any, make sure this isn't too warm. If it is too warm, we're in an over temp condition. It should always be cool to the touch. If you see paint discoloration on here, maybe heat lines down here, a paint discoloration throughout the transformer, let maintenance know right away, because that could be an indication that the transformer is going to be bad. Sometimes these have a long lead time, so these definitely just aren't sitting on the shelf at Home Depot. So if this thing was going to start to go bad, we'd want to let somebody know as quick as possible so that they can try to get one on order. So you don't want to be down 6 weeks or 16 weeks, depending on. But 12 kV to 480 is not uncommon, but they are handmade. We could walk around. If you see any oil down here in the trench, this should always remain dry. If you see any oil, this is oil filled in here. And so if there's any oil down here, it's leaking out, and that's going to be an indication of a transformer failure. It'll still run for a little bit, but I would recommend shutting down. Let maintenance make that decision. And then look for just general corrosion, heat discoloration, and oil dripping on the ground. It should always have a little bit of hum to it. That's normal. And any questions on the pad mounted transformer?
Is there a sight glass or anything?
It's inside the front door, and that's part of maintenance operations. That's it. Thank you.